rapid web prototyping with lightweight tools. And I'm going to give you a little bit of information about me before going into some of the background material on this talk. So I've been using Python a long time. I actually haven't been to PyCon in a long time. This is my first one in like 4 years, but I've been using Python since like before version 2, which is kind of crazy. And I use Python full-time in my startup, which is Parsley. So quick plug on Parsley. We are basically a web analytics provider for large-scale media and content websites. And so we do a lot of rapid web prototyping in our everyday work, so this is something I think about all the time. Parsley's website will load if PyCon's Wi-Fi eventually works, which it is just barely crawling into. Basically, what we do there is we visualize web traffic data for sites like The Atlantic and Fox News and these kind of large-scale content sites, and basically help them understand what content is working really well on the web. And we do a lot of web prototyping, especially around data visualization, although data viz isn't really anything in this course. I'll focus mostly on the web side. So that's Parsley. And then my links and things are in the slides right here, so I won't bother with that. The requirements for this course I listed as roughly what you can see in this slide. I think most people have this. If you don't, for example, if you're running Windows and you don't have a virtual machine at all, but you're just running bare Windows, you're not going to be able to like follow along exactly what's happening on the slides, because some of my slides use like Unix commands and stuff running at the command line. So in that case, it's better to just follow along sort of the code. And there's a lot of like web-based stuff that's happening in this tutorial. I also have a server set up where if people are using Windows and really can't get the local environment set up, still want to prototype, they can actually connect to a server that I have set up if the network's working. And you can just ask us about that at the break. So I'll skip over that. These are the two commands you want to make sure you're running if you're kind of in the advanced track of this course, which is you know that you have Python 2.7 installed and you know you have Git installed. And if that's true and you've cloned my repo, then you should be able to run git tag like that. And you should be able to see all 20 tags that I've set up for this repo. And the reason the tag system is nice is because if you basically check out any version going from tag 0.1 to tag 2.0, you're going to kind of move back and forward in time along the development of this web app. Kind of 0.1 is really, really basic. It basically just has a README file, right? And then 2.0 has a fully working Flask web application with MongoDB storage, deployment scripts ready to go, basically a nice rich UI using Twitter Bootstrap. So basically, I added all these pieces through steps, and the tags really let you see, kind of how the web app progresses. If you're not familiar with Git that much, there's still a trick you can use, which is if you go to the Git repo on the web, again, assuming that your browser, that the network's working well, you can actually see all the tags here, and you can actually click on any tag to zoom into that version of the code base, right? So that's kind of nice. I also included in the slide an interesting view, let's see. Let me actually jump to outline. I included in the slide an interesting view, which is basically the compare view in GitHub going from 0.1 to 2.0, which basically has every commit that I made throughout the lifetime of the project, along with all the diffs, right? So like this is all the code that gets contributed to the project. So that's kind of a nice view also if you want to like stay at the high level and not go really into the code yourself. Those are kind of your two options for beginners especially. So, okay, so let's see here. This is all the setup stuff that I covered in those setup steps that people should have gone to. But the bottom line of the setup was basically just to save people time in class. I'm going to skip over this portion of the setup and then kind of see where people are with setup when I get to those different parts. This way it's just not boring, right? I just find it'll be easier. So we're just going to get kind of right into it. So let's see. So what is rapid web prototyping by my definition? Well, it's basically the ability to go from an idea in your head to a web app that you're sharing with your friends, right? That's basically the rough idea. It's the same kind of thing that used to happen with me with Python generally, where I go from an idea in my head to a piece of working Python code. But now I think you can actually do the same thing with some small tools on the web and using Python. And the nice thing about web apps as opposed to Python programs is that your friends actually care about them, right? Like Python programs, you show it to your friend, like I show it to my good friend or my girlfriend, and they just stare at the screen and they say, who cares about a program, right? It runs at the command line. But a web app you can show someone and they'll actually really be engaged with it. And I actually have found in my work, where I work with a lot of engineers all the time and Python engineers, that there's a lot of reasons that people don't like to prototype web apps, like these weird biases they have against it. I guess they view coding in pure Python, like at the command line and building database schemas and things like that, to be sort of real computer science. And then web app development, they just think to themselves, can't a UI developer do that? Why do I have to be bothered with that, right? So I'm going to try to like pull you guys away from those biases and see why it's actually a really important skill to be able to go straight from the idea to a prototype. The other thing is that I think software engineers on a whole are very creative people. And I think that the important thing in rapid web prototyping is that you can really use all of your creative faculties. So go all the way from having the idea to maybe wireframing that idea on pen and paper, to sharing that idea with people and using your communication skills to get feedback from them, to then putting together a quick clickable prototype that someone can actually view in the browser, but maybe doesn't do anything yet, to then maybe exercising your back-end design skills and getting the thing to really work well. And so the rough model for a web app that we'll be working with is sort of drawn out on this slide here, where essentially we're going to be building a web app using a Python framework that's super lightweight, that's called Flask. That's on the top right there. When it gets deployed, it's going to use some really nice lightweight deployment tools, which are Nginx and uWSGI. And when it actually gets rendered in the browser on the left, we're going to basically abstract from you the task of design and let you just instead get to the structure of your application in HTML and get some decent default stylings going with Twitter Bootstrap. So if you're not a designer, don't worry, because you can actually build really good-looking web apps without being a designer, it turns out. So that's kind of cool. The last piece, which is the least important piece, is the persistent data storage on the bottom right. So I think that's the shift, right? Everyone thinks that's the most important piece. We're going to do that very last, and you're going to see that it's going to be 2 or 3 lines of code, and then suddenly things are persistent. But before that, you will have de-risked everything about the idea that you were developing. So that'll be a lot of fun. So let's see. Let's go into these biases really quickly. So one of the things that I see is this computer science backend bias. So how many people here studied computer science? So like most of you guys, right? So I think it's true that my professors and anyone I meet in computer science would say that the most important problems in comp sci are like data structures, NLP, operating systems, cryptography, all of these like deep research areas. What's that? Queuing theory, exactly, right? But I actually think that these are just the most interesting problems to introverted computer science people, right? So the most widely used software in the world doesn't actually really deal with these problems, or if it does, it outsources it to like system software in like a open source library some way. So if you think Twitter, Facebook, Gmail, and Reddit, what makes these tools so compelling to users isn't that they had really good queuing software, to take the example. What made it compelling is that it captured a user experience that people cared about. And so you're proving an idea about what you think someone might enjoy using is really about trying to get an idea in front of them and figuring out if that idea actually sticks with them and they want to come back to your web app. And that's a very different set of problems than all of these algorithmic problems. By the way, I love all these algorithmic problems. I just think that a lot of times I meet engineers who basically ignore this bottom half and only focus on the top half, right? And I don't think that that's really appropriate, especially for the way computers are used today. So the second fear that I see people have is unskilled design bias. So basically, if you look at a great designer, if you ever go to like dribble.com, you think to yourself, man, I can never make a design like these people. They're amazing, right? They're these like beautiful, rich, textured designs. So I can't make a web interface. But actually, with the modern tools that I'm going to work with you guys on today, you can make a web interface even if you have absolutely no design skills. And I have none, and I've made plenty of web interfaces, right? So I think that the other bias to get over is just you don't need a designer to build a web app. You need a designer if you want to make your web app like super, super compelling and like richly textured and designed, sure, but not to actually just get the idea going. The last, or the next kind of bias that I see is really a SQL bias. So web frameworks like Django, for example, sort of center around the way to store your data. You know, the whole models concept is that you model your data and then all these things start working. And it's the same thing with like Ruby on Rails and these other frameworks. So they sort of treat their core purpose in life as organizing the web application around your SQL database. That's how a lot of frameworks are written. But I actually think that in the early stages of a project, you can get away with not having a database at all. And we'll actually do that in here. Like we'll just kind of skip over the database step. And so if you get rid of the database, it turns out that the web framework becomes a lot simpler all of a sudden and full of much less magic. And then you can kind of get things done quicker. And then probably the most legit reason that people hate web prototyping is polyglot complexity. So what I mean by that is that you just have to know a lot of programming languages to get things done on the web. There's JavaScript, HTML, CSS. Then there's your web app programming environment. And you kind of have to put those all together and use things like template languages. So it's basically now you've got 5 programming languages in your head, and it just seems really messy. It would be better if you could just write Python code all day. And this one's pretty true. But what I'll show you here is that basically frameworks on the JavaScript side, like jQuery and Bootstrap, kind of abstract a lot of this messiness from you. And so you don't really have to know that much about them in order to do good work. So really what we'll be doing in this class is beating this backend bias back by flipping web development on its head and starting from the sort of like user experience and then kind of like iterating our way toward the backend, right? Instead of starting from the backend and building a UI around it. So any questions so far here? OK. So let's see here. Actually, I want to skip to. OK, cool. So I just skipped to slide 33, just out of my knowledge that I can save time that way. So basically, the 3 steps we're going to take in this course are, first, we're going to do what I'm calling the first fake. So we're going to build a JavaScript and HTML web clickable with jQuery and Bootstrap and no Python code yet. And I'm actually going to show you some Python tools, though, that make it really nice to do this quickly and like kind of prototype at the static level really quickly. But we won't actually be building like a true web app until the second step, which is what I call get real, right? So you're going from the fake kind of static clickable where you're kind of making a user think they're clicking on something that's working, but really it's just like a prototype, to something that actually responds to what the user clicks on and does some work in the back end. And then the final step is going to be shipping it, right? So we want to ship this web app to an actual web app server, get it running, give it a URL, post it on Facebook, watch it explode, right? That's kind of the goal. So those are kind of the 3 steps we're going to take here. So there's a question that I get a lot when I kind of talk about this process, which is why bother faking it, right? Why not just go real from the get-go? And I don't really have to tell you guys, if you're computer scientists and software engineers, that building an app and shipping it is a lot of steps, right? You're collecting feedback at a lot of stages. You're writing specs. You're connecting people and communicating with people. It's just a lot of steps. And I find that when you do things, when you try to build the right web app, the right way from the beginning, you can spend months before you ever find out that no one actually gives a hoot about your web app, right? No one actually cares. You've shipped something that no one actually wants to use. And you could spend months ending up there. So the other problem is that when you're building something fundamentally new, this process just fails altogether because all you're looking for is feedback, right? You're building something new so that you can find out, is there a there there, right? Like, is there a reason that anyone should be using this? So my goal is to basically let us skip from step 1 to 9, just sort of prototype our way out so that you can get real feedback right away. OK, So what we're going to do in the course, which is kind of cool, and this worked out really well the last time, I hope it works out with you guys, is we're going to take like a specific idea that I'm proposing here, and we're going to actually have members of the tutorial wireframe the idea. You're going to find that you guys come up with a lot of different ideas around the little kernel of an idea that I present here. So the idea is Reddit for clickstreams. So how many people here use Reddit overall? Well, not that many. A lot more people in the US use it than people at PyCon, I think. So the idea with Reddit for clickstreams is that Reddit is cool, but explicit voting is annoying, right? So basically, I personally never really vote on things on Reddit, even though I consume a lot of content on it. And I think that there's only like a minority of the users who actually do. So, but the interesting thing is that I think a lot of people like sharing stuff, as like the social web has shown. So people don't mind submitting links and seeing other people kind of work with those links. But who wants to take the time to kind of upvote and downvote them? You know, that's kind of an annoying explicit step. So the proposal here is, how about we come up with a Reddit-like site where whenever something is submitted, if it gets resubmitted by anyone else, like they basically submit the same URL. Yeah, go ahead. Oh, for those of you who don't use it. Well, yeah, that's kind of easy. So let's see here. Reddit is one of the web's top sites, first of all. And has absolutely terrible content on the front page. Actually, you should go to python.reddit.com, which is the more interesting subreddit, it's called. But basically, all Reddit is a site where there are little communities of people sharing links, and people upvote or downvote those links. And then the front pages basically represent the best stuff. And there's a little bit of a little decay algorithm. So essentially, the longer that an item has been live, the lower it'll appear on the front page. And it's like kind of adjusted by how much people are upvoting it on the front page. So it's basically a content aggregator. And it's a very popular site. There are subreddits from anything from Python and Java to programming, to politics. So there's like basically little communities centered around topics. And it's built in Python, and I should say it's open source, so it's actually great source code to browse. Although I think probably as a beginner, the Reddit source code is too complicated, right, at this point, because they had to deal with sort of real scaling issues. But yeah. So that's Reddit. Sorry, I should have thought about explaining that. And so my Reddit is Reddit for clickstreams, which is basically, there's no longer this vote button on the home page. Sorry, let me pull it up here. There's no longer these vote buttons on the home page, but instead, merely submitting a link gives a link a certain amount of points. If someone else resubmits that link, it also gets more points. So basically, it'll detect that the URLs are the same and upvote it. And if someone clicks on the link, it'll also get more points, right? That's sort of my notion of like Reddit for clickstreams. So no one ever has to vote. It just figures it out. That's the idea. So the next question becomes, is that actually an interesting idea? Does anyone care? I don't know. Maybe no one cares, but we'll prototype it anyway, right? And we'll just find out. So what's the next step once you have this idea? Like I had this idea. What was my next step? Well, I definitely didn't want to start building classes to represent things like front page, article, and link. That's just really boring. And I definitely didn't want to start using an ORM. I don't want to start researching high concurrency web frameworks, and I don't want to write a detailed web requirements document, right? Because those are all really boring, and no one actually cares about those. So instead, what I'm going to do is I'm just going to build it, like from scratch. And my first step for building it is pen and paper, which is the part you guys are going to help me with. So for pen and paper, I think personally that the first step for any good prototype is to draw it. And I think pen and paper is actually the best medium for a rough sketch, because all the digital prototyping tools are really kind of lame, I think, overall. And we have really good, like even the worst drawer among us draws a better prototype than you get out of a prototyping tool after spending like an hour, right? So the three things for you guys to understand about prototypes are there are three sort of spectrums to think about. Well, actually, I covered hand-drawn versus digital. There are two spectrums, low fidelity versus high fidelity. So when you're drawing a prototype, you don't want to go as deep as to draw every link, draw, what text is going to appear on the page. That's really too high fidelity for this. You're going to do that when you build it, right? Instead, you want to go low fidelity. You want to basically be like, here's how the page is going to be structured. Here are where the general content areas are going to be. Here's kind of the flow that someone's going to take through the site, right? And the rough metrics I use for this are, you want to answer these 3 questions with your sketch. What does she see? What does the user see when they come to the site? What can she do? And why does she care? Those are the 3 questions to answer in this little sketch, okay? So this is the first kind of like interactive non-coding portion. So I think Ramesh already handed out paper to everyone, right? Yeah. So there's a bunch of pens here, which I'll just start having people hand out, and so like. No problem. Oh, thank you. Thank you very much. I'll fix that up. Would I swap the I and the E? Yeah. Cool. So this is going to be really fast, this sketch, right? So I'm going to give you guys 5 minutes. Everyone will sketch something individually, and then we'll kind of talk about the sketch I came up with, and I'll pick a few people to like share their sketches, whoever's kind of eager to share, right? But again, the idea is to go for low fidelity. So basically, having seen sort of, I gave you a couple of kernels of ideas, having seen that Reddit is sort of this content aggregator that we're going to be dropping off the vote buttons and kind of focusing on this implicit voting behavior. You want to think about what happens when someone goes to a website like that? How are you going to display the content? You don't have to display it the way Reddit is, right? I'm giving you the kernel of an idea, but you could come up with like completely different ways to display things on the site. And then the other thing to think about is the real interaction flow, right? So you're going to have a couple of different user types, someone visiting the site to consume content and someone visiting the site to share content. So you might want to think about like how each of those user types is captured in your little sketch of the user interface. And so we'll just spend 5 minutes on that, and then we'll kind of get into it. give you guys one more minute. And then actually, do I have any volunteers who really want to share their prototype? Oh, come on, someone wants to volunteer. Okay, you'll do it, good. Anyone else? Okay, great. So, so what we're gonna do is, it's gonna be tough for people to, in this environment, for people to see it. So what I'm gonna do is take pictures of your prototypes on my phone, and then I'll put them up on the screen. That'll kind of make it work most easily. So I'll come around to do that now, and then everyone else can finish up, and we'll go into it. So, hold on a sec. Okay. Check. Yeah, good to go? Cool. All right, so I'm going to keep going a little bit. The prototypes are going to upload. Obviously, the Wi-Fi is a little slow. It already got one done, and then I'll pull them all up. They'll show up in my Dropbox eventually. So, but actually, I'll cover just this over here in the meantime, which I didn't get to before. So what you guys will see from the prototypes, actually, and I can already tell just by taking the pictures, is that people come up with dramatically different things. So even though I set all your expectations with like what web app I expected out of this thing, I bet every single one of you drew something different. And in fact, a good exercise is like at the break, just like swapping with your neighbor and seeing like what they drew versus what you drew, and see that everyone comes up with different ideas for what this web app should be, which is of course a great indication that if you had just built it, you know, all the way through from the get-go, you would have pretty much have made a mistake guaranteed, right? Because if everyone's coming up with a different idea, then there isn't really a right way to do this, right? So this here is a little layout of all the tools that I consider to be like my sort of ideal rapid web prototyping toolkit these days with Python. So basically on the left, I have sort of more of the front-end focused tools like HTML5, Bootstrap, jQuery. On the bottom, I have more of the Python-oriented tools like Flask and Werkzeug, which are the tools that we'll go over at the Python level. And then on the top right, I have more of my like prototyping and orchestration tools. So, so for orchestration, what I mean is like the way I actually make it so that with a single command, I push out to a live server, right? In the case of live reload, it's a way for me to get instant feedback in my browser about code that I'm working on for a user interface. Or in the case of Emmet, which is a renamed project, it used to be called Zen Coding, it's a way to basically work around the verboseness of HTML and get to like having your content and structure put together nicely really quickly. So there's all these tools that you can use, and you can kind of review this slide on your own, but this is basically what's covered throughout all the slides here. So let's see. Let's see if this finished, actually. Oh, yeah, it did. Sweet. So let's actually pull that up. Oh, no, I'm not logged in. That's going to be terrible. Well, we'll see if it comes fast enough. Let's see how this does. So this was mine that I did in like 1 minute, right? So basically, I'm like the biased one. I basically put together something, even though I know roughly how the web app's going to turn out, right? But basically, this gives a good sense of like low fidelity wireframes, right? I have some rough navigation at the top. I have a little bit of information about how the links are going to be displayed with a score and with a date indicator. And then I have a rough indication that when a user clicks submit, a dialog is going to come up that lets them just type in a title and a URL and submit it. And that's really all the interactions there are to the site. But actually, ooh, that's me. Actually, there's a lot of weird and interesting ideas that people came up with here. So this was your, oh no, wait, sorry, this was yours, right? Okay, so actually, why don't you just project and explain your wireframe really quick?
Okay, well, the submit thing was going to be on the right. I didn't draw it, but the idea was that you just got a little preview of what the site looked like, and you could hit the space bar to pop it open, escape to move it down.
To close it.
If you liked it, you slid it up. If you didn't like it, you slid it down.
Cool.
And you're on to the next one.
Cool, very cool. So he had something that was more, just for people who couldn't hear, he had more of like a content preview. You could kind of expand and get a preview of the content on the site, and some keyboard shortcuts for moving around as well, right? So that's pretty dramatically different in the way it looks from this one. And then this version right here was, who was it? You, okay. Why don't you explain that one? Yeah, great. So basically more of like a tiled layout, and there's actually different sorts for different parts of the site, different sorting approaches for different parts of the site overall, right? Very cool. And so this was you, right? So you want to explain that? Cool. So in your case, the submit didn't even need, for example, the title, because you were just going to auto-detect it out of the link. And it's right on the same site that the main display is, right? So already you're seeing that basically even from these three somewhat randomly chosen examples, there's like very different approaches to how to do this web app, which I think is kind of the point here. So now I'm going to walk through, oh yeah, I should think about breaks, right? So let me see what I have in here. Where did that go? Oh yeah, so I think I'm going to give you guys a break at 2:30, if I remember correctly, something like that. That probably makes sense because it's 4:40 that the course goes until. So we'll keep going here. So in my version of this wireframe, which I showed on the screen briefly, I basically had three areas of functionality. Basically, links, submit, and search, where you could, basically the links kind of look just like Reddit. The submit was a new form that you would get to, and search was a way for you to just filter down all the links that have ever been submitted to the site. So we're actually going to jump right into code now, but this is more like on the web side. We're going to actually use basic HTML to kind of get the structure of our app working, and then we're going to pull in Twitter Bootstrap, and we're going to start like prototyping out the way this wireframe is going to look. And I'll show you some interesting tools at the same time. And then we'll jump in a little bit closer. So close this. Okay. All right. So the steps I'm going to take here in my source code tree, if you've got my tree cloned and you actually have the virtual env set up correctly, you should actually be able to activate that virtual env and see, rapid env on your screen. And then you should be able to actually run serve.sh. But I'll actually just kind of show what serve.sh is doing, just so you know under the hood. Basically, it's going into the static directory, and then it's running live reload with port 8000. And what live reload is doing is it's basically just running a little static web server. at port 8000. So in my case, because I'm at like the most recent version of the web app, it's actually going to show me a static mockup. That's kind of where we're going with this web app. This is sort of the static prototype I put together for the wireframe that I had earlier using Bootstrap. But for now, we're actually going to build it from scratch. And so to do that, you have to go to the URL /preview/index.html, like this. And what you're going to get here is actually just a big box that has nothing in it. But what's actually going on here is that this is a code mirror box. So it's actually like a syntax highlighted like HTML editor over here. And if you actually type in simple HTML like this, then you're actually going to see hello world appear at the bottom. So what it's doing is it's just listening, and every 300 milliseconds or something, it's like re-rendering the DOM and just showing you exactly what you output there. But this code mirror box is actually like really, really nicely enhanced for you because it has this open source project called Emmet built in. And so Emmet actually gives you some shortcuts for building really quickly HTML documents. So if you actually type exclamation point and press tab, you're going to get quickly a standard like doc type ready HTML document. And it's actually going to position you into the title area, so this will be my prototype area. And then I'm in the body, and now I can actually type tags like hello world again. The other thing that Emmet does is it gives you some shorthands for just building up quick DOM elements. So if you're familiar with HTML, you probably know that tables are kind of annoying to make. So with Emmet, you can do something like table with the right caret, and then tr times 3, and then td times 3. And when you press tab, you're actually going to get a table with all of those elements prototyped out, right? So it's just like, now I can actually even be really fancy here, and I could say td with sample value put inside it. And now I have like an ugly table with a bunch of sample values in it, right? So I use this tool all the time. Like I had Zen coding installed on Vim and all these things, but when they ported it to JavaScript and I could get it working inside the browser, now I use it all the time in the browser because it's just like you get to see it right away, right? As you're typing it in, HTML is appearing. Now what's kind of boring here is that this styling really sucks. And this is where you start thinking to yourself, yeah, go ahead. Live reload. So it's live reload -p 8000. Yeah, I also just have a little script in here called serve.sh, which just goes into the static directory and runs live reload. And by the way, for those of you who can't get this working on your machine, if you can get your web browser to open it, it's kind of a hard URL, but if you can get your web browser to open it, and you go to hacknode.alfpoint.com:9999/preview/index, you'll get the same thing, and you could just play with it in the browser. I'll actually paste this inside the Google Doc here, so that this way, if you guys can't get it working locally, at least you have somewhere you can go to get it working. But yeah, live reload to actually run it in here. And I'll actually explain what live reload's doing in a sec. Yeah. So live reload gets installed into the virtual env, so you should actually be able to just run it once that virtual env is activated. And you just need to go into the static directory in my code checkout, and then run live reload from there. Yeah, go ahead. Mm-hmm. Well, you don't need live reload for this step yet, but yeah, we'll see if other people run into that afterwards. And actually, it's not super important to have it. I just use this as a static web server. Any other questions from the setup standpoint? OK, cool. So the next question is, how do I get from this ugly table, right, to something that actually looks decent? Because I can't show this to my friend, right? They're going to be like, where does sample value begin and sample value end, right? So the other trick is I actually added our own abbreviation to this code mirror thing, which is Bootstrap. And if you press Bootstrap and press Tab, then you're actually going to get an HTML document that has actually pulled in the Twitter Bootstrap CSS style sheet, the Bootstrap JavaScript code, and jQuery. So now you have like a lot of stuff on your page to play with from a styling standpoint. And then it also, just as a convenience, creates a div element in the center with the class container. And that's something that Bootstrap expects. Basically, anything that's inside the div called container starts to get Bootstrap grid styling applied to it. And now's probably a good time for me to explain what Bootstrap is. But before I do that, I'm going to recreate that table and show you how it looks in Bootstrap. And then I'll explain what Bootstrap is, and it'll be pretty obvious. Right? So now if I'm inside this container, I might do something like create this table. And then now I'll actually create 3 headers, sample header, like that. Oops. So create 3 headers like that inside a row. Yes, I can. Is that better? Thank you. And then I'll do tr times 2. And I'll do sample value. So right now it's still unstyled, but the second that I add the class table here, or at least it's supposed to be the second I add the class table. Let's see. Table. Let me see, actually. That's still unstyled. So, oh, that's why. I shut down live reload, so it's not getting Bootstrap. OK, let's bring it back up. There we go. So the second that, so when it's just normally styled, this is how it looks on a Bootstrap-enabled page. Still not great, right? But the second that I add the special CSS class table, then this table starts to actually look pretty good. So what it's done is it's actually taken all of the width of the container, and it's put some nice grid lines between it. And there are these other CSS classes that Bootstrap enables, like table striped and table hover, which now are actually striping the cells of the table and adding an interaction where when you move your mouse over it, it actually highlights the table row. So this is pretty cool, right? I basically had the same markup that I had before, but now, even though I'm not a designer, it looks decent, right? That's kind of a good first step. The other cool thing here is we'll just kind of say this is our rapid web prototype. The other cool thing here is that it's not limited to tables. Basically, Bootstrap enables this behavior for all of the standard HTML elements. And so I'll just go quickly to their website if it shows up. Oops. Twitter Bootstrap. So they basically have anything from navigation elements to forms that you can use to a grid system for laying things out in a tiled way. Basically, a lot of the metaphors that you guys prototyped, right, on your sketch, you can probably model them with Bootstrap elements, right? If you thought about ways of like using the width of the browser or tiling things, there are ways to do that with these components. And the base CSS basically takes all of the standard HTML elements that you're used to, but makes them look pretty decent by default, which is just really nice. So simple color schemes, simple ways of making form elements look a little bit more palatable. And then even higher level components like actual drop downs like this and navigation bars like this. So what's cool about Bootstrap, though, is that if I get rid of this table really quickly, and so I basically say, like, oops, let's actually look here. Oh, I closed it. OK, Twitter Bootstrap. Components, navbar. So if you look at something like a navbar, what you'll see is that what Twitter Bootstrap does is it takes advantage of the fact that div elements and span elements in the browser have no meaning by default. And so they add a bunch of CSS classes that you're meant to put on div and span elements, where the div elements basically tell Bootstrap the structure of the thing you're trying to model. And then the CSS classes you pick kind of layer on the style for it. And so in this case, a navbar is basically two div elements. It's a div element for the navbar itself and a div element for the inner area of the navbar. And then it'll basically pick up on things like if I have a list, an HTML list that's called nav, then it'll actually lay it out like little navigation links. And if I have a link that's called brand, it's going to lay it out like it's a logo for the page, right? And so we can kind of do this over here. We can basically say, I want to create something that's called a navbar. I want to have a navbar inner element. And I want to have something called a, let's say that it'll link to my blog for now. And we'll call it Rapid News. And add class equals brand. So already you can see that like the navbar is starting to show up over there. And now if I basically do ul nav, which is what it's expecting, followed by a list item with the value nav times 3. What did I mess up there, actually? Oh, right, they have to be links. It's kind of annoying. So you have to do li times 3, and then each of them has to have a link. Oops, sorry. Now my little shorthand language is actually difficult. So let's just do this. So nav1, nav2, nav3. And you see, I'm not a designer, but I got a good-looking navigation bar, right? So, and you can actually, when you hover over these, it has like a decent default styling. And when you add class equals active to any of these, then it does this nice like sunken in look. So that basically it looks like it's a depressed button. You'll see this like all over Twitter Bootstrap. There's basically little styles you can use to model what are pretty typical user experiences. The other cool thing is that Bootstrap is also responsive, which means that you can actually make it so that let me actually pull that up from my slides. So, yeah, hidden phone, visible phone, that's what it is. So you can actually make it so that the other classes that you add to the brand are hidden phone, right? And then what's going to happen is, just by adding the class hidden phone, Bootstrap has this internal media query that basically figures out if your resolution is smaller than the typical resolution of a phone, I'm going to hide this element dynamically. And so when I tile now my web browser to the left side, the brand goes away, but when it's full screen, the brand is there, right? So you can even be a mobile-friendly designer without any design knowledge, right? And just using one CSS tag, which is pretty nice. So that gives us our navigation element. So actually, we're pretty close. Let me actually just finish this up. We're pretty close now to having kind of the prototype of what I was expecting here. I'll actually use some snippets to save some time, since you have the rough idea here. So let's see. So yeah, let me use this for my navbar instead. So in this version, I actually have nav elements, and then I also have a little drop-down, which is another Bootstrap element you can use for having like the user profile, where we can actually keep track of things like what the user actually submitted and things like that. And you can see here that it's actually pretty similar to the nav. You just create a list, you call it drop-down menu, and then you get that behavior, right? So that's kind of that. Let's say that this was called links. This is called submit, and we don't even need this third one. And then down here, yep. Down here I'll have the table example. Yep, so that's kind of like a decent first cut, right? Obviously I can play with things like adjusting margins and things, but with very little HTML code, you have something that sort of is already workable, right? So this thing doesn't save anywhere, right? So I mean, that's another thing I should have warned you about probably earlier, is that you have to copy paste this out of your browser and then put it in a text editor to save it. It's not very smart, right? But you could then take this and put it in your, save it somewhere, and in fact, you'd get something that's pretty close to this, which the only difference with mine over here is that in my case, I modeled the search bar over here, and I also have some like JavaScript animation for pulling in the elements, which I describe in the slides, but I decided to skip over just to save time, right? But this is actually nothing more than static. It's just static Bootstrap code that I just put some behavior into. There's even in the slides covered a way to do a modal dialog with, this is kind of cool actually, so delete that. And so in the slides, I actually even describe in more detail how you can do like a modal dialog with Bootstrap, which is basically this here, where on the first visit to the site, it brings up this modal dialog and like tells you what the site's about, but then on every subsequent visit, it doesn't actually do that. And I did that without a backend even, right? So I think I was just trying to even show like how far you can get without even ever getting into the backend pretty easily. This is just as easy to put together as the other example I had there. And now every time I refresh the page, that modal never comes up again. So you can kind of explore that at your leisure, but I'm going to sort of zoom ahead so that this way we get more into the Python side of things as we go. So any questions so far? OK. So let's see here. Emmet. So yeah, it's Emmet spelled with one T. Used to be called Zen Coding, but now it's emmet.io. This is the project. And CodeMirror is basically, if you guys use IPython Notebook, which we'll actually use later, IPython Notebook uses CodeMirror as like the code editor also. It's basically just a JavaScript code editor that works in the browser. So that's why I could combine these two tools really easily, right? Like just take CodeMirror and then take Emmet, pull it in, and tell Emmet that it should listen on keystrokes on CodeMirror. And then that worked pretty well. So, OK, so now, I also should sync you guys up from a code standpoint. So I'm going to close I'm going to close live reload for now, and I'm going to see what tag I can bring us to actually. So where I am here, yeah, is v0.9. OK. So if you check out v0.9-flask, which is this tag, let me put it at the top, which is that tag at the top there. If you're using the Git version, you can check it out that way. If you're using the zip version, just go to the folder called v0.9-flask. Then you can actually see the state of the code where basically there are just two Bootstrap files, index.html and submit.html in the static directory. And these two Bootstrap files basically just have some sample data along with a little bit of JavaScript code for implementing that animation. And the kind of annoying thing is that the submit version, which I'll pull up right here, oops. Localhost 8000 /submit.html. So by the way, I'm just running live reload here, and then basically I'm getting this submit form. So the submit form you'll see is just a separate page with the same boilerplate around it as the index page. And so that's really where I'm trying to show you guys how to go from static to the dynamic web app, right? Because basically there's a shared boilerplate around both of these pages, around including Bootstrap and the footer of the page with all the JavaScript code. And we want to get rid of that and make it so that it's like a shared code base, not that we just keep copy pasting code everywhere, right? So we're going to do that piecemeal just by going on to templating, the kind of laying out the templates for this thing in the right way. So the other thing to note is that there's a lot of stuff missing from our prototype. So no server means that we can't submit this form. Even though I can pull it up, when I press submit, nothing happens. And I don't yet have a link tracker, a way to do link redirects. And I don't yet have a scoring algorithm. So there's nothing really wrong with that, because we're providing a really good clickable UI. But we basically can see already that we've got this like header-footer code duplication, and that not having a backend, although it's nice to be able to show someone a submit form, it's probably pretty frustrating if like when you click the submit button, nothing happens. So we should probably actually implement that right now. And that's where we'll start getting into Flask and Jinja to actually do this. So actually, this is a perfect time. What's that, sorry? You could fake the submit, but the submit won't go anywhere, right? So it's perfectly fine. That's totally true, yeah. And in fact, if you wanted to, that'd be a good exercise, is just like with jQuery and Bootstrap, bring up a modal that's like, thanks for your submission, but then basically discard the data, right? And that's like the ultimate fake, I guess. So, so the next step is going to be us getting real. I'm going to give you guys your actual. The 5 minutes isn't right. I'll probably give you more like a true, 20-minute break, I guess, so that this way we can just charge through for the afternoon and you guys can get your coffees. I'm already seeing like afternoon energy levels decline, right? So grab the coffee, get the boost, come back here at 2:50, right? And because it's 2:30 right now, and then we'll kind of continue along the path. Okay? Yeah, go ahead. Like, how did I get into the code mirror browser? You can't view the source of the presentation in the browser? Or what do you mean exactly? Do you mean the slides that have source code on it? Oh, right. So, if you want, you can press C, and then you can go to this O button down at the bottom. This like weird-looking O with the slash through it. And then it'll go into outline mode, and then you can actually just jump over to the code and copy paste it. That's the way to do that. Yeah, exactly. So anyone who still needs setup help, I or Ramesh can help you guys out, and I'll definitely help you out, right? And I made the terrible mistake of telling you guys to check out v0.9 and then telling you guys to run CodeMirror and Emmet and all that. But it turns out 0.9 doesn't have CodeMirror and Emmet in it, only master does. This is just because I didn't go back and add it to an earlier tag after I had added it to our project. So if you want to use this kind of like live editor thing, this live editor thing right here, which now I don't even show, right, because I'm in the wrong branch myself. Okay. If you want to use the live editor thing I was demonstrating earlier, then what you need to do is you need to actually check out master first, or if you're in the zip version, work off of the last tag. Or actually, sorry, I have to explain this too. The zip version is missing it altogether, unfortunately, because I should have redone the zip before the tutorial started. So if you're in the zip version, you won't have this tool installed, so you need to go grab it from GitHub. But if you have the Git repo installed, then you have git checkout master, then pip install live read load if you don't already have it installed. Then you just serve, and then you navigate over to here, and that'll get you to the code editor window, which is this thing. I got a few questions from people that was like, what the hell is this thing? Like, kind of how does it work? Why does it work, right? So I just want to like be clear about how all the pieces fit together. In this case, I'm using live reload just as a static web server. It's just serving files off of the file system, which includes this little like preview tool that I just have installed. So there's a directory called preview. The directory has an index file in it, and it also has a JavaScript file called emmet.js, and a directory where CodeMirror is installed. So CodeMirror and Emmet are both just JavaScripts. That's all they are. They're not like Python packages. In fact, someone discovered that there's a Python package called Emmet, also misspelled with a single T. That's not anything to do with this. It's just there's an ambiguation problem there. Emmet is nothing more than this JavaScript file. CodeMirror is nothing more than its JavaScript files. And those two things come together in this little index file that just includes them both and has a little bit of JavaScript code that implements the text editor and implements the preview pane and implements the Emmet enhancement of the text editor. And it's just a tool I built quickly out of the, I wired the two open source projects together and just laid it out this way. So it's like a homegrown tool, if you will, right? Live reload does nothing more than just serve up static content. I'll actually show you guys what live reload actually does as the first thing in the tutorial right now. But all I was using it for was to get a static web server running. You could have just as well done it this way, which I actually cover in the slides. You could have just as well run python-m simple HTTP server like that. And then you would have also gotten a static web server running in your directory. It's like a little Python trick that this just does that. And when you go to localhost 8000, just like before, I just get a static web server. So that's all I was using live reload for there. You actually, there are reasons you can't, right? So yeah, but it's not a big deal. You can in most cases, and then there are weird reasons where just opening it in your web browser actually causes problems. Like that example code I have uses cookies, and cookies don't work when you run in file URI mode. So there's weird little things like that. I always just run a static web server just to avoid those issues. It's kind of the, yeah, it should be in the master branch, or in the master, ref or whatever. So, which one? Sure thing. So the Python command is this guy right here, which is python-m simple HTTP server, camel case with all caps HTTP, right? So, yeah. So those are both pretty nice tools. So live reload. What is live reload really? So I mentioned in the slides, which I didn't go on the slide, but it's in there. Is let's actually pull it up here. So live reload's actually not just a project in the Python land, but it's also a Chrome web plugin. It's actually a web plugin for a lot of browsers. In my case, it actually shows up as this little weird cycle icon up here. And the idea with live reload is that if you don't have a tool like this where you can just kind of prototype your HTML in here, or actually, I should put it this way. If you really like your own text editor for editing HTML, then the annoying thing with editing HTML is that every time you change it, you have to refresh your browser, right? So what live reload does is it's basically a browser plugin that listens for whether a file changes, and if the file changes, it just auto-refreshes your browser. So it's instead of having to hit reload, it's live reload, right? It just reloads as you're editing. So I can actually show this working, which is pretty cool, with exactly the same command as before. So basically, if I run live reload here, and then I pull this guy up, here's my code there, right? So the cool thing here is I'll move my code, I'll move my live window here, my code over here, and in my text editor, which is Vim in this case, I'll actually edit the HTML. So I will add a h2 element here that says hello class. Oops. And what'll happen if this thing's working correctly? Oh. Oh, well, that wasn't live reload. That was anti-live reload. I had to reload it. Let's see. There we go. OK. So I just removed it, and it refreshed, and you saw reloaded on the left side. And now if I add it and press that, then it noticed it on the file system and just refreshed it over there. So this just leads to a really nice kind of rapid prototyping environment as well, where you're like, oh, you know what? I actually don't even like the table header anymore, so let's see what it looks like without that. And maybe I actually want to put the score in the third column instead of in the first column, right? And then I could go do that throughout the editor. And you just sort of see the changes happening live in your browser. You can stay focused on the text. Works really nice if you have a big monitor, too. Because it's then you put the code, the live HTML on one side of your monitor and the code on the other, and you can kind of just edit things and see them happening. So all that's going on there is basically that this plugin is listening on this server, and every time this server sees a change, which actually if I do something like this, you'll see that every time it sees a change, basically it'll reload on this side as well, and then you'll see things moving around. So. Exactly, that's the Chrome plugin working with the backend server. Exactly. So, yeah, go ahead.
Is that the only dependency on Chrome in this demonstration, or is there something else that depends on Chrome?
No other dependency on Chrome. Everything, Bootstrap works with all browsers pretty well. It used to have like it used to have a sort of cutoff at IE7 or something, but now I actually think that Bootstrap has become compatible with like everything under the sun because of open source contributions and things. So yeah, everything here is pure web, works in every browser. Chrome just happens to be a really good browser for doing development in. That's due to not just a good ecosystem of plugins, but also the built-in WebKit inspector, which is this thing here, which is actually a lot more full-featured than a lot of other browsers, for doing this kind of stuff. The WebKit inspector is just the tool that lets you like actually, do things like delete nodes live in your browser and see what happens, which I tend to use a lot too. So, cool. So that's live reload. All right. Let me actually go back to the big component chart and see where we sort of are with all that. So let's see here. So we've got sort of this side of the house all figured out, right? I mean, we basically have this nice framework we can use for building the front-end app. And we don't have this side of the house figured out yet. That's where we're going now. The web server I was using so far was just live reload, but that's basically just a development server. So now we're going to start filling in some of the Python web app side of things and eventually get over to persistent data storage, right? So this is where we start going deep into Flask and into Jinja for templating. So let's see what slide I want us to jump to. Right on. So you can jump, if you're following along in the slides, you can jump to slide 80. And basically that's like onward to getting real. And now we're going to talk about web servers in Python really quick. So the cool thing about Flask is that, do people here know that Flask was actually an April Fool's project? Does anyone know that? Oh, no. Oh, that's a really important part of its history. So I first saw Flask, incidentally enough, on Reddit. I saw it on the Python subreddit. On April 1st, this guy open sourced this project, and he said, it's the micro framework to end all micro frameworks. And basically, it was an April Fool's joke to say that he saw there was this trend in the web community of micro frameworks. And this guy had actually written two really popular open source projects, which were Werkzeug, which I think I'm mispronouncing, and Jinja. Jinja is a very popular templating engine, and Werkzeug is a very popular WSGI compliant HTTP server and library. And so basically, he wrote this Python module that just imported his two open source projects and then declared that it was a micro framework. And then he open sourced it and gave it like a really nice web page with all this documentation. And like he was like, hey, and then it got upvoted on Reddit, and people were like, this is awesome. You can make web apps in like 3 lines of code. And meanwhile, no one realized that like he had just packaged together two open source projects that had been around for years, right? The funny thing about that is that then it became like a real open source project. So he released it as an April Fool's joke, but yeah, go ahead. Yes, that was the other part of the joke. So the smallest micro framework was called Bottle, and he named it Flask, right? So basically, it was just kind of this geek humor happening on the internet, right? Typical for Reddit, by the way. And I thought this was hilarious. I tweeted it. I was like, oh, this thing looks awesome. I'm going to scale all my web apps with this thing, blah, 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 right? But then, lo and behold, a year passes, or maybe 18 months, and I'm using Django every day. And I track the development of Flask, and Flask turns out to be this like really legit project. And it's actually legit because what they realized, and the joke actually kind of became a reality, is that you don't need a lot to have a working web framework, right? Like, you don't need all this magic that, like, I love Django. I use it every day, actually, because we have an app that was built on Django, and I'm not going to move it over to Flask anytime. But the idea is that, like, if you want to build a web app from scratch, you don't really need to know that much magic to get it going. So the two pieces really are all you need. You just need an HTTP server so that you can run something locally that does something web, right? And then you need templating, and the whole point of templating is basically to make it so you don't repeat yourself in the front-end code. And then you've got a web framework, right? That's it. And it turns out that Jinja and Werkzeug are both really nice designed libraries, very lightweight libraries for this. So this code example here is a pure Werkzeug code example that just creates a basic web server, a response to requests on port 4000, and the response that it returns is just hello world after printing the path and the headers from the HTTP requests coming in. So this is kind of going under the hood of a web server, if you will, right? I actually have, which I think I can do here. Let's see. Let's see how the internet works, actually. Oh, sweet. So I'd basically just set up a little IPython notebook that has this code in it. I don't need you guys to follow along for this. I think it's actually just more interesting to see it here, and then I'll tell you what to follow along with later. So, so basically, this code example here, let's see if it runs. Will it blend? Nope. OK. Oh, it's not working for me. I'll run it locally instead. That's fine. Leave that behind. Try to save some time, and you can never save time. OK, so IPython notebook. Sweet, OK. So here's my code, which was just on my slide. It's creating an HTTP server and running it. And when I run that code and I go here, all that happens is I get this thing. But every time I hit refresh, what's printing out are the request path, which is just slash in this case, right? And also all of the HTTP headers. And this is where you're sort of seeing the guts of HTTP come out, right? So Werkzeug, basically, every time it gets a response or request from the browser, you get this request object, and you can actually inspect this request object and see exactly what's going on. The cool thing here, which let me clear the output now, and restart the kernel. The cool thing here is actually that I can also show you that Werkzeug also has a special support for debugging web applications, which is another piece that's kind of critical to a web framework, right? When something goes wrong, you want to understand what's happening. And so in this case, I just basically wrote a web server that throws an exception. And I wrapped it in this Werkzeug tool called debugged application. And I actually even said to enable this thing called evalx, which is basically a way for me to evaluate expressions in the debugger. So now when this comes up, ignore how weird this looks for a second, because that's just IPython nonsense. But when this comes up, I actually now have a live debugger on the crashed web server, which you could use this for your own apps. And you could actually now like look at request.path, look at request.headers, and they'll just show up. This is like a live Python console in the browser, right? Of course, you never want to run this in production, only locally, right? In production, your exception happens, and then someone runs import os, os.system, you know, shutdown -r, reboot, you know, whatever. And that's not good news, right? So you don't want to run this in production. But locally, it's perfectly good. So yeah, so basically, this is a really nice debugging tool. And you can kind of just copy paste this example locally. So let me actually do that. Grab that, close IPython. Actually, I think I even have it here. Is it just simple? No. Is it rapid? No, it's not rapid. What was it? Oh, it's debug, of course. I named it correctly. So I kind of pasted it here. So this is it inside a Python module file, like that. And And then if you actually run this thing, which is python debug.py in the app directory, you get the same thing. This thing, but now actually the error message is a little nicer. It shows me where I am, and likewise, I get the request object. So here's one nice piece. We've got a web server. Not only that, we've got a web server that works kind of nicely where you can even debug things, right? So now the next piece is we just need templates. And then Flask is going to show us how to put a web server together with templates. And then we'll have these things called routes and some other tools. And then basically, we have all the tools we need to really rapidly put together a web app, right? So learning a lot at the same time as doing a lot, right? So that's kind of a cool thing. So let's see here. So the main things that our web app needs to do is validate that new submission form, store the recently submitted story somewhere eventually, calculate some scoring algorithm for listing links on the front page, implement that link redirector so every time someone clicks on a link, something actually gets recorded about it, and potentially even implement keyword search. Okay, that's what we need the programmable web server for. That's what the static part can't actually do. So the first thing we want to do is actually get into templating. And so this was that one project in the open source April Fool's joke, right? Which is the Jinja project, a templating language. And all Jinja does is basically make it so that you can create these objects called templates, which are just strings that have special placeholders in them. For example, these placeholders here execute a kind of for loop within the template. And these placeholders here replace values that you pass to the template with content. And so what I'm doing here in this little example, this kind of like minimalistic example, is I'm creating a template that creates a table of numbers and their squares, okay? And then I'm basically passing it a list of dictionaries that just have the form number and square. So you can see number and number times number for number in range 10. So basically, this is just a list of dictionaries with numbers and their squares. And I'm telling Jinja, render this template with this data. And what comes out is that table. And so what Jinja basically gives you is just a way to be programmatic about the way you produce HTML. That's really the best way to think about it, right? Programmatic in a way that isn't the ugly way of like writing print statements that concatenates HTML, right? So Jinja is really nice because it runs kind of standalone. You can even run it at the command line. This code here is an example of that, where essentially all it does is it loads a template off disk in your current working directory, and then loads a JSON file from disk also, and then renders output based on that. And so if you had a template file that looked like this, which is similar to my example from before, and you ran it with a JSON file that looked like this, and ran this command, which I actually have in the code base, render.py squares.jinja.html, then you would actually get the table with this output, right? So templating isn't complicated, right? This is basically, you can do this. This is just Python code at the end of the day. I actually have a nice IPython notebook for this to show it live. So let me do that really quick. IPython notebook. Templates. So this is that. So basically, so that you guys get a sense here, this is what the data looks like for the squares. That's just the Python list. And then this is what rendering looks like for that table. So this is 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, right? So this is pretty simple stuff. Where it gets interesting is when you start wiring things together. So now, what I'll tell you is that, oops, sorry, refresh. I told you that the other thing we needed to do is write some functions that can get some data around these articles. So the way I start to think about this from a prototyping standpoint is I stub out these functions. So you can think of a function for getting the top articles, a function for searching for articles, and a function for inserting an article. And these are just basic stub functions right now. And now what I'll do is I'll actually set up our first Flask app. And this is where the April Fool's joke really made a lot of sense, right? Because in, what is this, 5 lines of code, I'm setting up an app that's listening at a root URL, and it's rendering a template called index.jinja.html, and it's passing it some articles that I'm getting out of a function I'm calling. And this is basically a web app, right? It's basically end-to-end working. So if you take this code and copy paste it, which we can do right now, Flask app structure. So I'll just call this myapp.py. And I'll paste this guy here. Oops. So if you just have a real, this is basically importing from Flask a Flask object and the one utility method that we actually, or function that we need, which is called render template. This is from my own code, for my stub code. So basically I could replace this, right? I could just say top articles, return an empty list, right? And then this creates the application context for Flask. This double underscore name business, I could actually just put a name for an app here. But what people do by convention is they just use the name of the module as the name of the app. This is because Flask, if you get big with Flask, it actually supports having multiple apps in your single Python process. But for now, you can just use this as a recipe. And then there's a function which is called a view function. And the view function is where actual Python logic is going to happen in response to requests. So in order to bind a function to a web request, you use a very natural concept from Python, which is just a decorator. And the decorator is just a decorator called route. And this is what Flask calls its routing support. So basically the idea is this application object that I created exposes a decorator that I can use. And the decorator takes as an argument a path specification for what path at the web server should be listening and then routing requests to this function. And notice that the function takes no arguments. And this is actually a pretty clever thing that Flask does. Even though it's passing you the request, it's actually passing it in a way that I'll cover later called a thread local context. So there's actually a way to get the request if you need it. But if you don't need it, you actually don't even have to bother with saying that you have to catch the request. So in a lot of web frameworks, you kind of have to put like request here, and then there might be like other required arguments. But in Flask, you don't even need that. It can just be a bare function. And then render template, all that is basically sugar on calling Jinja, actually loading up your template in Jinja, and then passing any of the keyword arguments to render template into that template itself. So let me actually open up the template to show you guys what that looks like. So in the example I took, I was trying to convert my static example over to a Jinja template. And so I actually separated the template out into a base template, which is this thing called layout.jinja, and then the individual templates themselves. And in this case, what I'm looking at is the template that implements the table of links for the rapid web prototype app. I won't go into too much depth on that, but just to show you that this is actually a Jinja template file. We're going to cover a lot of what's actually in here in a sec. So then that gets rendered up, and then it gets returned from this function. So what Flask then does is it figures out, oh, what that function returned is a rendered Jinja template. So now all I'm going to do is render it as HTML in the browser. That's basically it. And so Flask keeps it really simple. The code down here basically just says that when you run this example from the command line, it should run the app in debug mode. That's all. So what this makes possible is for me to basically save this, say myapp.py. Flask is now running right there. I can go to localhost 5000. Ah, good. There's an assertion error, so we can figure out why. Yeah, and so I have a more advanced template here than I probably should, so I can check out an old tag to show you guys this. But it's using, in this case, something that I don't yet have. So let me do that really quick. I just ran the module. Okay. So I just said Python myapp.py, and boom, it runs a Flask server. It defaults to 5,000, and then you can just like pass a keyword argument, port equals 5,000 or 6,000, whatever. I don't know the exact history of whether Jinja came before Django templates. I do know that Django, it's based on probably based on Jinja V1, right? Yeah. So.
They're almost exactly the same.
Yeah. So in general, the Django versus Jinja approach is basically just that. In the old versions of Django templates, there was a lot of restriction on how much like kind of code you could do in your templates. These days, they've kind of loosened that a little bit. But the Jinja approach is basically you should be able to do almost anything you can do in Python in the template. It's just that maybe you'll just choose not to use all that power, but you still have the power if you want it. And there's some nice stuff in Jinja related to macros and the way that their hierarchy is set up. So, but this is probably too, my tag is too advanced here. So let me do, probably 1.1. And then probably simple. Let me just check if this is what I actually want. Oop. All right. Yeah, okay. Let me look at what that's looking like. So yeah, actually, I'll get us a little bit more grown up first. So if you want to follow along from a Git standpoint, you can actually do git checkout v1.1 Jinja. And then you're going to be able to be in the rapid web app directory. And the file we'll work with is app.py. And oh, by the way, if you guys don't know Git tags that well, you should know that if you do v1.1 and then hit tab, on almost every operating system, Git will complete to the tag, right? So v1.1 and then tab, and then you should get the right version. And if you look at app.py in here, it's just slightly more complicated than the one I was just showing you. So there's still the index route, but then there's also, I set up search and submit. They're both pretty simple. And then I basically just kind of cleaned up the code a little. So let's just talk about these really quick, which is, in the case of search, I actually am using a feature in Flask, which is that you can actually have the root capture an argument for you. So basically, if you go to /search/ any keyword as a URL, then what I'm going to get called is this search function with the keyword being passed to query here. So this is just a simple way to do mappings between your function arguments and your roots. And over here is just a different example, which is if you want to handle get and post because you want to support form submission, then that's all you have to do, just add methods get post here. And now it'll actually support both. And you remember how I mentioned how you don't need to worry about the request object? So in Flask, if you import the request object from the Flask module up here, then whenever you need it, if you access request in the context of a callback, that will be the current request. So it basically moved it moved it in a way out of it having to be in your function arguments into a strange global variable that changes value depending on which request you're currently in, right? And Flask has all this documentation that talks about what that actually is. But essentially, from a programmer standpoint, this is probably the only bit of magic that Flask does, just to clean up your code a little bit. From a programmer standpoint, it's like you import the request object here, and anytime you access it here, it's just automatically pointing to the right request in whatever context you're in. So that's kind of the idea. And what else is kind of cool here? Oh, yes, the static folder. So the Flask app, in this case, which maybe let me just tile this a little nicer. So the Flask app also knows in debug mode how to serve up your static files if you need it to. And all you have to do is pass these two keyword arguments, static folder and static URL path, and it'll actually pull all of your static files out of that directory. And so we already had all our static files in /static, because that's where we were doing the emit and code mirror kind of rapid prototyping thing. So all I'm doing here is I'm basically just telling Flask, oh, mount all my static files from that directory one level up. And when you mount them at the URL /static. And so now when I'm running the server, when I run the server here, and I go to, for example, localhost 5000 static JS main.js, what I get is the JS file that's in the static directory being served by Flask just as a static file. So that also means that within here, all of these references that I have in the source code to like Bootstrap, for example, those are getting served appropriately from that directory. So actually at this tag level, we're at this interesting in-between place where I've converted the static files into templates, the static HTML files, but the JavaScript is still sitting in the static directory. And so you can actually prototype in both places, whichever one is like more comfortable for you at this point, right? So let's see. Let me close this stuff out. Any questions here so far? Let's see how we're doing on time. So I think we're good on time, actually. So it's 3:24, and you guys are here till 4:40, right? I'm right about that? Yes? OK. So we have to like kind of close up at 4:25 or so and then do the surveys and things. So OK, let's reload this. So here's kind of what Flask gives you out of the box that basically implements everything you need for doing web prototyping. I already covered the request context and URL routing. Template context is basically those variables that you pass around the render template function. So that's just getting data into your templates. Sessions and redirects are really nice tools for basically associating data with the user as they move throughout your app, and redirects for basically sending them different places. So we'll actually use redirects to implement the click redirector later on, right? The sessions functionality is actually implemented the same way as the request module is. So what that means is all you do is say from Flask import session, and now you have an object that you can add properties to, and that object is going to be the right thing for every user, automatically handled by Flask, right? So it really keeps the code nice and simple. Yeah, go ahead. So I think by default, it just stores it in memory. And then if you want, you can provide a session backend. I'm pretty sure that's the way it is. But yeah, I think so. So let's see here. Can get out of this. So just to go in a little more depth about routing, this is like what you might imagine Flickr to have designed their URL routes as, right? So they've got an explore folder and then an explore path and then a photos path, which are basically to explore the site. And then this is sort of how their URL structure is for users. So a user's individual photos are just at photos/username, but an individual photo is at photos, username, and then some integer ID. And so Flask lets you model this with this handy little validation syntax where you just say it's an int called photo ID, and it'll capture that for you and pass it all cleaned up into your function here. So this was kind of the way we modeled it for Rapid News. So jumping ahead a little, let's see. I'm going to jump to slide 114. Yeah. So one thing that kind of comes up in web prototyping is basically we had that little side discussion where we said, oh, you could do almost everything static if you really wanted to, right? And a big question that comes up is like, what goes where, right? So now you've got a Python web app context controlled by Flask. You've got potentially a module that has all of your sort of business logic, right? You've got templates. You've got HTML, Bootstrap, and JavaScript, right? And so the question is like, do I put my core logic, in this JavaScript bootstrappy thing, or do I put my core logic on the Python side? And the truth is that there isn't really a good answer to this. That's sort of like what comes out of experience, but I can give you like some rough guidelines, which is you really should think about it in terms of, are you doing your app as a single page app, or are you doing your app as a multi-page app? And basically the difference between these is single page apps are sort of the trendy apps you see now where basically everything happens in the browser. And so there's very little page reloading. You know, you click on something, instantly something loads up. You never see like a full page reloading. And they also tend to be the kind of like least web-friendly apps. But you know, sometimes people do it really well to do both. Multi-page apps are sort of what you're used to on the web, right? So things are kind of laid out at multiple URLs, multiple page loads. And so if you're doing a traditional multi-page app, then it's pretty clear that actually you want to keep your web app layer pretty clean of logic. You want to keep most of your core logic in some module in the Python area. And you want to make your front end like pretty lean and just basically rendering data, right? If you do single page, then you're basically moving a lot of logic into the JavaScript area, right? And sometimes people don't even use Python for this so that they can share logic between client and server. So that's kind of like one decision you sort of have to make up front, which is if you're trying to do your app as a multi-page app, then there's kind of a decent way to lay things out. But if you're trying to do it as a single page, then you kind of have to do everything in JavaScript up to a point. So that's kind of one big area to think about. But I'm going to think about our app really as a multi-page app because it's just simpler, especially for prototyping. So, so this is sort of a flow of how the Rapid News app actually works, going through all of the use cases we described. So when a browser requests slash, that actually gets handled by Flask, and then Python logic gets called to get the top articles. And then when we call render template, we create a new template context. That calls into Jinja. Jinja gets the data, and it renders an HTML response. Then when you get a response, the user sees the front page. He can click submit. That results in a new Flask request. Another template context is created for the submission form. That's then rendered with Jinja. And if the user sees a submit form and actually submits the new article, maybe there's like some form validation logic that happens on the form. Then that actually comes back with errors or not, and the user moves on. So this is like pretty clear. It maps to our views overall. There's like templates. There's a template for the index page and then another template for the submit page, and it's kind of clear what you're supposed to do in either case. So that's sort of, if you look in Git at the difference between the 1.0 tag and the 1.1 tag, that's basically where I took our static app and converted it into this multi-page web app, more or less. You can kind of do the diff on your own and see it there. So now we're going to move on to some more kind of advanced stuff with Jinja. Yeah, go ahead. Yeah, so it's like more work to make your single page app actually support like proper permalinked URLs. It's more work to make it gracefully degrade when someone doesn't have a JavaScript implementation that's up to snuff, right? And it also like tends to be something where a lot of these tools that I showed you just stop mattering, right? So for example, like debugging the web server where there's like a Python stack trace. In a single page app, any logic error is probably going to be a JavaScript error. So then you're just going to be debugging inside the browser, basically. So it's just like you're kind of making the whole web request flow less important, which is not only more work for you to like support the old web paradigms, but it's also like a little bit more work to debug. But there is a benefit. The benefit is like the user experience can sometimes be really awesome as a result of doing that. So I basically just don't recommend you do it for prototyping because I don't think it's like essential, right? I don't think like having your app single page is going to be the difference between someone validating your idea or not, more or less. And it's more work the way I look at it. So any other questions you got? Yeah? Okay. So yeah, so basically, this is what's really cool about Jinja. Jinja gives you this macro facility for cutting down on code duplication. So just like you can kind of create functions in Python that remove duplication from your code, right? You can create macros in Jinja that remove duplication from your templates. And so macros like this basically create little functions like link tag and script tag, which if you use these repeatedly, it'll kind of factor out the repeated noise in your templates. So in this case, it's basically just a way for me to reference CSS sheets and script JavaScripts without like repeating these like tags, which are very verbose over and over again. And so this is how you would end up using something like that. You can actually, just like with Python, you can actually treat your templates as modules that you can import from. So in this case, it's like I have a util template that then has these two macros. You can actually import those into your template, and then you can call those just like this, and you can call the script tags just like this. And then basically you're actually getting those tags rendered in the browser, which is quite nice. The other thing that Jinja has is it has this like hierarchy thing, which you're probably used to. Like, how many people here have already used like hierarchical templates with Django stuff? So like a few of you guys, right? So hierarchies basically let you do real factorings, where you can say, I have a base template that then gets specialized into 5 or 6 different sub-templates. And so in that case, you put the base template in this guy. You say that the sub-template extends the base template, and then you override these things called blocks. So let me actually just show you that in code. It's the easiest way. So when I did the conversion from static to template, I basically took all that boilerplate and put it inside the layout template. So this is like the boilerplate that gets Bootstrap going. And then this is more boilerplate for my nav bar. So this is like the nav bar at the top of every page. And then I basically put a block in the center called body, and the body block is where my sub-templates can specialize this template and add more behavior. So now if I look at index, index is really simple. It basically extends that original template, and then it defines the block body and actually renders that row of links. So for example, right here, it's rendering each row of the table for every row that's past the template. And so you can see that this reduces the code duplication because I no longer have to repeat that boilerplate here. And if I look at submit, it's the same sort of thing. I just extend the layout template, and then I don't have to repeat the boilerplate, but I can just create the Bootstrap form here. And the Bootstrap form will get injected into the page in the right place. So this is a very powerful facility for just like now factoring out your code, which is basically your next step for getting real. So let's see. Let's jump ahead a little here. Yeah, let's talk about this really quick. Yeah, I'll give you like a little flash sense here. So Bootstrap actually gives you a nice, forms are basically this perennial problem with web apps, right? Everyone has to deal with forms pretty much. And Bootstrap gives you a way to lay out your forms using these things called control groups. And so basically you wrap your forms into divs that say this div is a control group and this one is too. And here's the link and the title form elements from before. So I could actually paste these in the code mirror thing. Let's do that. Serve. Localhost. Oh. All right, I have to go to master again. Serve. Go there. Scrap. Let me wrap these. So. A little bit of a nasty paste, but I did it that way. So basically, what's going on here is that when I tell Bootstrap to make these guys control groups, they sort of treat them as logical parts of the form so that the label and the and the input element will be aligned in kind of a designer-friendly way. And then it'll also like do this nice thing with the placeholder attribute, where it'll put this like grayed out value in there, and then if I like start typing over it, it'll kind of go away with the placeholder, right? So now I could just like type, google.com and Google here. And it does like this nice highlighting on it as well. So this is kind of nice, but you can already tell that like even though these form elements are nice the way they're designed with Bootstrap, with like the with just having to use these little class attributes, you still kind of have a lot of boilerplate in producing each form element, right? So it's like for every form element, you need a control group, you need a label, you need a div for the control, then you need an input element, right? So it's kind of repetitive. So macros are also a really good fit for that too. In this case, the macro looks something like this, where essentially I create something called an input macro, and it just takes that bit of code that I have there, and it just says, give me a name, give me a description, give me a type, and give me a placeholder optionally, and then it just templates this thing all up. And so then if you look at the way these end up looking in your code base, you can just say, I want an input for link, which is going to be labeled link with a capital L, and I want an input for title, which is going to be labeled title with a capital L. And as you can see, you're just kind of building up pieces that now you can make like a pretty large form, but you know exactly how it works because all it's doing is rendering this macro back here, which just has a bunch of placeholders in it. The other interesting thing about this macro is that it uses request.form, which is a special thing that Flask does with Jinja. Flask will automatically put that special bound request object into every template context. And what that means is that I can actually access data that's in the current request upon every template rendering without having to explicitly pass that data to the template. So in this case, I'm basically saying if the form of this past HTTP request already has a value for this form element, then I want to stick the value into the input area as its value. And what that's supporting, yeah, go ahead.
Would that be considered within the practice though? I mean, from my perspective at least, really we want the controller to be able to massage data, do what it needs to with data before handing it to the template.
Yeah, so I mean, I think it wouldn't be good MVC practice to do much else with the request object, right? Like for example, to, I don't know, start trying to parse the headers or something like that, right? But in this case, actually, Flask already does some sanitization to the form submission, which is what the request.form object actually has in it. So, so it's kind of the cleaned, submitted form data, right? And so, so in this case, I think it's pretty safe to do this, and certainly safe to do like when you're just hacking around. There might be an argument that it might be smarter to put it into the view function and then just manually stick it into the view. Yeah, either way. But this just gives a sense of how you can use that object from the Jinja context. Other questions? Cool. So I won't go over these in detail because they're a little boring, but basically there's also some macros I put together for handling error submissions, which is just some Jinja stuff to help with, it's actually part of this macro. Basically, if errors happen during the form submission, this will actually use some Bootstrap classes to make the form elements look like error elements. It'll like highlight them in red and like put a star next to them and that sort of thing. So it's just even more logic I'm pushing into the macro so that I don't have to repeat it. And yeah, this here is a good example of like how you would implement kind of validation in your business logic layer. So in this case, I basically wrote a little function that validated the parameters that were submitted to the form, and then basically just did some checks like that the title had to be greater than 2 characters, less than 150, that the link could actually be reached, and for this I used like Python's URL open module to actually like make an HTTP request to the link, see if it comes back with something. And then if there are any errors, basically this guy returns some error objects, which then I use in the template to show that the form submission was invalid. So maybe instead of running through the code, I'll just show you it working, which I think is just if I run this guy now. Oh, right. I better do that now. I have my personal, oh, sorry about that. I have my personal PyMongo or Mongo instance installed on a VM, so I have to actually boot that up to show you this last step. I wonder if there's a tag I can jump to before Mongo came in. Let's see, v1.8 server. Server. Okay. Yeah, this is it. So this is v1.8 server dash server is the tag where I finished the Flask app fully, but I didn't yet add the database. So it doesn't need PyMongo yet, which is nice. So I checked that out, and then I ran python app.py run server. Notice that in this case I couldn't just run it anymore, and that's because in a tag in between, I added a little convenience tool that makes it possible to run subcommands off of your Flask web app. It's this little thing called Flask script. It's a little plugin. You'll actually see it here. Basically, I wrap the app in what's called a manager, and then the manager lets you have little subcommands registered. So one of the subcommands is run server, so you need to add that now to app.py. When you run that, you get port 5000, and now if you go to localhost port 5000, you're going to actually see this data being rendered from the backend into the browser. No database yet. The data is still stored in memory. But the submit form is actually doing real validation. So when I hit submit, it says this link couldn't be reached and this title isn't 2 characters. If I type Google here and hit submit again, this link still can't be reached, but now Google's validated as a good title. And then if I type google.com here, hit submit, it says, thanks, we received your submission. And by the way, at this stage, it discarded the submission because we don't have a database yet. So we're kind of at that stage you were asking about earlier. Yeah, go ahead.
So is that kind of single-pagey? Is that...
No, that's multi-page. That was very traditional, what I did.
You don't have time to do page reload and install.
Yeah, because it's fast.
Yeah.
Yeah, it's just I mean, my computer's fast, and for whatever reason, the Google response came back quickly, so. Because Google's fast, right? Yeah, exactly. They're just down the road, so that was easy. And actually I could show you that here. I did actually print the data I got from the form at the command line. So it said inserting google.com title Google, just a little dictionary. We're actually not that far from storing it in a database now because we're going to use a pretty lightweight database for this too. So let's see here. So I have 2 options for which way I can go. I'll actually poll you guys for this. So one way I can go is I can go a little bit deeper into templating, ways that you can use templating to help you out, specifically filters, which is this like nice other form of code reuse. Or I can skip that, go straight into tying the database in, and then see if we can actually make it to code deployment. So who wants, yeah, go ahead. That's a good idea. So you're talking about the web documentation? Yeah. So the Flask docs are pretty nice. Actually, I even I should mention this. The Flask docs are nice, but you know what's even nicer is the source code. So the source code is only about like 1,300 lines, which is, it was 2 lines at the April Fool's release. They added maybe 1,000 lines to make it actually like support everything fully. But they actually intentionally are keeping the framework small. So like they're choosing not to add features so that they keep it, so that it's something that can fit in your head, basically. And I think it's a great virtue. It's actually, my most productive days at my day job are when I delete large swaths of code, right? So like I think the Flask project views it the same way. If they can delete code, they're going in the right direction. So you can read the documentation, which is quite good. It just so happens that the guys who developed this are also just huge fans of documentation because they also develop Sphinx, which is another like popular project out here. So, so you can find out that there's like plenty of docs about this, tutorials, and probably the most important thing, like everything at the beginning parts of this are pretty tutorial-y, but the interesting things are when you want to start growing up your Flask application, and that's where they added a little bit of code to the core framework around things like where do you store configuration values, how do you handle events inside your app, that's what signals are, and the ways of like kind of modularizing your web app. This is actually pretty recent. From their recent release, they had this feature called blueprints that makes it easier for you to like modularize separate apps that are all running under the same server, more or less. So there's a lot of good depth in there, but basically, as you can see, it kind of gets out of your way for the early stage. And Jinja has its own documentation, so it's kind of a separate project, even though it's used heavily in Flask. And so the template language and everything can be found really easily there as well. So actually, yeah, that's right. I was going to poll you guys. So who would rather go straight into databases and deployment right now? OK, almost everyone. Who would rather stick with like filters and templating? Very few people. All right, let's go straight into the databases. So, all right, so we're going to jump. There's a lot of stuff in here that you guys can look at that's pretty interesting related to that. But we're going to jump to. So I'm going to give one quick overview of how I implemented the link tracker, because it's really easy. I just want to show how easy it is. If I want to make it so that anytime someone clicks on a link, that link gets tracked so that we can treat it as an upvote, all I do is register a new view called click with the root /click, and then I say, grab the URL out of the request arguments, so request.args URL, track the click, which is going to be like a database call, and then return redirect to the URL. So Flask's redirect function is just going to redirect me there. And in the Jinja template, all I have to do is create a macro that looks like this, track link, title URL, and then it uses a little Flask utility called URL4. And what that's doing is basically the URL that appears inside this link tag is going to be the URL that corresponds to the root I registered called /click, right? Or called click. And so what's nice about that is you don't have to like hard code like HTTP localhost or anything like that. Flask knows where the web app is running and will write that URL in appropriately. And the parameter, you don't have to deal with like URL encoding or query parameter encoding. Flask will just encode that correctly because I pass URL equals URL, so it's just going to stick that as an argument. And so now it basically say, when I want to do a tracked link, I call this macro, so that's what's here, row.title, row.link. And so what'll happen then, which hopefully I can show you guys, let's see, get checkout master, app.py, run server. No data. Ah, right, because I didn't submit any links. Right, so this one's actually working off the database now. I'll show you how the database works in a sec, but let's submit a link. Link recorded. OK, and it's going to be kind of small, but I'll just paste it. So when I copy this link address, what's happening is this is the address. So you see that it actually figured out I want to go to click, and then I want to pass URL as the parameter, and then it's going to URL encode the URL as well for me, right? And so that's what it actually uses. And when I click on this, because it's using a redirect, I'm just going to get to google.com. But meanwhile, which there I am, but meanwhile at my command line here, I can see that my web app responded and said, I'm tracking that someone clicked on the link, google.com. So that track event actually got registered. So now we can use this to actually influence the database, which is kind of the next step. So let's see here. So let me jump. I'm going to jump over the deployment stuff and go into databases, and then I'll come back to deployment at the end. There's a trick I learned at my last presentation that I should have changed it around. So I think what you guys are getting a sense of from the Flask and the Bootstrap presentation is that these tools are really, really small and lightweight, and you can kind of piece them together, and then you get working web apps. So on the database side, how can we do the equivalent thing? And it turns out there's a lot of databases out there and a lot of flame wars about databases. I mean, it's basically the heaviest. I think I really feel bad for people who run database companies, because it's like every week someone writes an article about how their product sucks, and then the next week they write an article about how their product's great. It's like that just keeps happening ad infinitum, right? So I want to give you guys the quick speed dating tour of alternative databases out there. But my first question is how many people here already have written traditional SQL web apps? Pretty straightforward stuff, right? Okay, and how many people here have played already with alternative databases like Search, NoSQL, et cetera? So about half of you. Okay, cool. So this will be, for the other half of you, this will be a little bit of review for the half of you that I already know, but I'm just going to do a quick speed dating of which databases I think actually matter for prototypers, and then go into the one we chose, which is MongoDB for this use case in particular. So, so basically there's this whole SQL, NoSQL debate. Ignore that debate. It's kind of silly. There's just a whole lot of databases out there. NoSQL is a classification now for some of them. And that basically, the two that I think you should know about on the kind of lightweight side are Redis and MongoDB. So Redis is a data structures database. You can just basically stick the same data structures that you tend to store in Python right in there. And all you get basically are keys and values. You get some higher level data structures that are efficient in different ways, but you don't really get the notion of a table. You don't get the notion of really a query language. It's basically stick data in, it gets stored in memory, you can pull it out. It's really high performance though. So it's really good if you have low importance data, low importance, right? You don't care about it because it can go away really easily, right? And high performance, maybe I think my web app's gonna get a lot, for example, a lot of analytics tools use Redis because they know that no matter what, there's a lot of analytics data, even if you don't have that many users. So you just want to be able to scale up to high performance pretty quickly. MongoDB is a document database that gets flamed a whole lot for a whole lot of legitimate and not legitimate reasons, right? But basically, it stores JSON documents. And so how many people here are already familiar with JSON? See, what's awesome is whenever I ask that in any room of developers, everyone raises their hand, which is so not true for how many people really know SQL in detail. I get 1/3 of the people raise their hands, right? So basically what's nice about MongoDB is that you don't really use SQL, you just store JSON documents. And if your use case is simple, like this web apps is, for example, then you can kind of avoid a lot of the complexity with a bigger database. But then you get a whole bunch of downsides too. So everything's a trade-off in computer science, right? The good thing here is that if you have simple data storage use cases and some high-performance use cases, like some analytics use cases, then MongoDB is a great fit. And you don't have to learn SQL. You just basically store Python dictionaries in a database, and then you can query them. That's basically the model that it uses. So it's kind of nice. The other ones that I just want to point to, because actually I saw that PyCon has some coverage of Elasticsearch. I think the person who's giving the Elasticsearch talk doesn't happen to be here, right? No, okay. So Elasticsearch is a great search engine that actually has a whole data model that's very different from SQL and even a database like MongoDB. And so if you're thinking about search use cases, I have a whole lot of content and I want to let people find things by keyword and things like that, then there are dedicated databases for those. So basic thing to point out though is that a lot of these databases are pretty complex. Postgres and Solar, for example, people just develop expertise in them altogether. The reason I chose MongoDB is because you don't have to learn anything about SQL. When you install MongoDB, you get no configuration and basically a Mongo server is just running. The PyMongo driver is really cleverly designed. It just lets you open up a connection and then insert Python Python dictionaries into the collection. And they just appear there, and then with just 1 or 2 commands, you can query arbitrarily within those documents, right? So it's really, really simple. There's a Mongo shell, which is actually just a JavaScript shell. So you basically, if you know how to do JavaScript in your browser, you sort of know how to work at the Mongo shell, right? Which is kind of nice too. And it actually scales really well in a lot of use cases, although fails in some. But for prototypes, it's like kind of the perfect database. It's basically the database I now use whenever I'm starting from scratch. Because you can always upgrade to SQL later, but you don't want to take on too much complexity at the beginning. So here's how you kind of store your first data in Mongo. You open up the shell. You basically say, I want to use this database. And then the database gets set as this variable db. It's just a JavaScript variable there. And when you say db.articles.insert followed by a JSON dictionary, you're actually going to get that document in your MongoDB. And when you say db.articles.find, and then pretty is actually just like a pretty printer they have built in, it's going to output that document right here. So in this case, I input a dictionary that had title Google and link google.com, but I got one more key out, which is this special ID field. And this is just something in MongoDB where anytime you insert a document, it gets a special object ID. It basically auto-creates that. You don't have to really worry about it, but it's useful because then when you like reinsert documents, that's the way it knows how to like update a document and like find the original copy before it updates it. So you can kind of ignore it normally, but basically you're getting back this dictionary. And using the PyMongo client is basically the same thing. So you create this PyMongo client like this. Then you say client.hacknode1, for example, and that gives you a database. And then if you go one more level in, you get a collection. And so a database is basically just a grouping of collections, and a collection is a grouping of documents, and that's the entire model in MongoDB, right? That's it. It's just, you don't have to learn anything else. Databases don't have schemas in MongoDB, so you create a database just merely by inserting a document in it, and then all of a sudden you can start searching on the fields of that document. So again, you're kind of skipping that step too. Querying PyMongo is pretty straightforward. You grab a collection, and then you call collection.find. And just like you would with a SQL library, you get a cursor at that point. So it's sort of like a lazily evaluated pointer on your data. And if you then convert that pointer into a list by calling like list call.find, it's actually going to go and fetch all the data from the database and return it in a pretty simple format. As you can see here, it's just a list of dictionaries, right? So that's what the PyMongo driver does. It just converts the data in the database into dictionaries on the Python side. So implementing our quote-unquote data access layer is 4 lines of code, right? So basically, from PyMongo import Mongo client. This is like, let's say, our database name, hacknode1. And then I just write a function called getCollection, and it just returns Mongo client database.articles. And that's my collection. That's all. So now if I want to actually revise my code for inserting an article into the database, all I have to do is say, get my collection, then insert, call.insert the article into the collection. And that's it. Basically, what happens at that point is the data is actually in there. So we could just try this at IPython. It's pretty straightforward. And so, by the way, in my prep, I mentioned that if you wanted to, you could install MongoDB. But it's kind of, for some people, it's kind of annoying. If you do have MongoDB installed, you should be able to just run Mongo and get to the shell. If you don't have it installed, then just follow along with me. It's simpler. It's pretty easy to install in reality, but sometimes it causes problems. So I'm going to say, from PyMongo, import Mongo client, some DB, some collection. So that's my little collection. And now if I just say insert title Google, then it gets inserted. If I say call.find, I get the cursor. And again, if I call list on that, I get my little dictionary back. And that's actually a database, right? So it's storing that data. I can query it. I can index it, all those things. But it's pretty straightforward. Yeah.
There was no schema, no nothing. That's just brand. You added, you set it, and it appeared as you
as I put it in. The first document that comes into a collection makes that collection, and the first collection that appears in a database makes that database. So that's basically it. And then, if you need to kill the collection, you can do that. So you can actually say call.remove, and then it'll actually drop all the documents out of it. But yeah, that's it. And you can now, if I actually open the Mongo shell and I say show DBs, I had just created this DB called sumDB. And if I say show collections, I had created this collection called sum_col. And so that's the collection in Mongo. And now this is me querying it from the Mongo shell. So there's nice equivalence between, by the way, that's the other thing I love about Mongo is there's perfect equivalence between the Mongo shell code and your Python code pretty much, right? Like, I mean, that was pretty much indistinguishable except for just getting the handle on the collection. But all of these things are pretty similar. Like, you just say, if I say here col equals db.sumcol, then all of these tools that I can run here, like find and sort and pretty and everything, are available also on the PyMongo side, which is great. So yeah, that's our simple and so this is what I love. We thought that the database was going to be a big deal, and then it was just that's it, that line right there, right? So that's storing the articles, and then over on the upvoting side, I actually use a pretty nice Mongo feature, which is just called increments. They call them atomic updates because of some fancy stuff they're doing. But basically all this is doing is, if I want to make it so that when you insert an article, if the article already exists, I should actually upvote the existing article by 5 points. But if the article doesn't exist, I should insert it anew. This logic implements that right here. So what's going on is that first I get the collection. I check whether the link already exists in the collection. And if it doesn't, if it does, if it's not none, then I found an existing article already, and so I'm going to upvote it. And so upvoting is basically a Mongo update command where I just say update the link. The criteria for the update is the first document. So I'm saying update the document whose link matches the existing link. And then the update document basically tells it what to update. So it says increment the score field by 5. It's a special thing. This is on the Mongo documentation page. There's a few of these. There's ones for basically implementing ranges, and ones for implementing increment and decrement and atomically setting items on a document. The reason there's this atomic thing is because Mongo, in its replication model and everything, it has basically some built-in support for concurrency. And so if you use the atomic operators, you can be guaranteed that when you're incrementing here, you don't have to hold a lock on the database to make sure you're going to change that value. So it simplifies some of these simple things like this. Yeah.
What about testing if that is not there and inserting it?
Yeah, so there's this special thing called an upsert, which is basically just for that. And it's just it's a update check, an insert check, and then if it's already there, it updates the document. Otherwise, it inserts it. Yeah. Yep. So this is pretty straightforward, right? So we're just incrementing the score by 5, or we're just inserting the document from scratch, right? And then here, this is also pretty straightforward. This is just the tracker, the click tracker, right? All I'm doing is basically when I track a click, I just update the document whose URL matches it, incrementing by 1. So in this case, my algorithm for the database is basically resubmits get 5 points and clicks get 1 point. And we could see what that behavior is, or we could toy with different values and see what happens, right? And I haven't even gotten into decays and stuff like that, but that's basically the idea. The other nice thing here is that Mongo also supports some basic search functionality, although it's very hacky, but it's perfect for prototypes. If you want real search, definitely go for Solr or Elasticsearch. But this is actually just a regex match. So I can basically say if I want to support searching, then I'll just do a find on the title field and then pass the query as a regex into Mongo. And that just does a regex search across all the titles of all the documents in the database. So So you can kind of get pretty far with some really basic queries there. Oops, sorry. So let's see. Any questions on the Mongo portion? Okay, cool. No. Exactly. So like I said, it's perfect for simple use cases, right? If like in this case, right, since all we know is that we're just going to have some place where articles are submitted and stored with scores, you don't really need, normalized join support across tables and ways of linking things together. And the MongoDB argument for all the join stuff is that if you do need it, sometimes you can pull it off just by embedding the data you need into the documents. And then in the cases where you actually do need joins, they are very explicit. They say, upgrade to a SQL database, right? I have to tell you, there are a large range of use cases where you really don't need them, right? And especially when you're just getting going, the amount difference of code between what I just showed you and doing the equivalent thing, not to mention code and understanding for doing the equivalent thing with a SQL database, is pretty big, actually. So don't store customer data in Mongo. Anyway, go, yeah. Great question. So if you guys didn't hear it, he was asking, is it automatically adding indexes for your keys so that you can do finds on them? Or do you have to do that yourself? So actually, it's not adding indexes, but my Mongo instance is being kind of polite and letting me do table scans, right? But basically, if you run the pymongo command ensure index, and you pass any number of keys, then Mongo will actually just in the background make sure that an index is built for each of those keys and make those queries even faster. So the cool thing is that this is all about, I think my feeling about what Mongo does is it sort of just like lowers the barrier to entry in the same way that like Flask does for web programming or Bootstrap does for HTML, which is basically, yes, of course, when you start scaling up, you're going to need those things to be indexed, but when your data set is 20 documents, you're not going to need it. So when you need to scale up, all you do is add one line of code which says ensure index on title or ensure index on link, and then Mongo will run that in the background and make sure it's indexed. As a result of that, it'll use more memory, and then you might have scaling issues later on, but you kind of are getting there already. So you kind of don't have to make the decision up front, more or less. Other questions? Okay, cool. So let's see here. We are at 4:10. We have until, I think we have more or less like, I'm going to say basically 10 more minutes, and then I'm going to give you guys the survey to fill out and everything, and then kind of answer any general questions and things. So, so what I'll cover for the next 10 minutes is basically just a little bit about the deployment stack, right? Like how you could actually get this web app running. I'll just show like me deploying the web app and show how I kind of made that work. And then kind of we'll close up there. And I think we actually made pretty good time here today. So, so basically, let's jump back now to slide. Where is it? Right, to slide, slide 165, which is it's basically talking about Fabric. So actually, a great question would just be, who here has already used Fabric? Okay, so about half of you guys again. So for those of you who already use Fabric, this will be a little bit overview, but for those who don't know what it is, let me just give you the quick overview and then show you how I built a deployment fab file here, right? So the quick overview is that everyone loves SSH. Everyone likes to script deployments to servers with SSH, and Fabric is just a tool that makes it easy to script deployment to servers with SSH, but writing Python code instead, right? So when you create a fab file, which is this file here, basically what you're doing is defining functions which correspond to tasks that are going to run on remote servers. And so in this case, this little fab file, which is pretty simple, basically does the task list home. And what it does is run the Unix command ls-lha on the remote server. And this code up here basically says, tells Fabric to use my my like personal SSH configuration to resolve host names, and then tells it to use this host as a default host when I run the fabric command. And so what'll happen here is when you run fab-l in the checked out code, you're going to see a bunch of tasks available, and one of those is that list home task. And if I actually run that here, you're going to see that the output on the left is corresponding to the server it's running on, and then I actually get the output from the server. So this is basically the same as me like SSHing into the server and then listing that output. And what I've done here is I've actually created a bunch of tasks for setting up the server to be ready for deploy. And Fab makes this really easy with a few lines as well. So essentially, Fabric has this little utility called rsync project, which is in their contrib module. And if you do rsync project and then just pass a remote directory, a local directory, and a set of excludes. So in this case, I'm excluding like compiled Python files, my .git directory, the virtual env, and my like virtual env activator. So basically push all the source code. This will just actually rsync that code over to the server when I run fab deploy. So that's like a one command and bam, it's pushing everything out. Actually, I'll stop it because I don't want it to be slow. So all the task decorator does is tell Fabric that that's a task. And so it ignores the first time you use a task decorator, it'll register that function name as a task. And then any other function that's within the module won't be treated as a task. Because Fabric's default operation is actually to treat any function in the module as a task. So by using the task decorator, it makes it so that this doesn't become a task because it's just a utility I'm using. That's all it does, really. And then there's like a mapping of how it takes arguments for each task. So the cool thing here is that basically I've got, in the code, I have tasks for deploying the code remotely, restarting the supervisor service, which I'll talk about in a sec, which is actually what's running the code, running a dev server remotely on the server, which then I can connect to, so I can like debug my code live on the server. And this setup task is actually just it's a task you have to run once when you first have the server set up to basically set up the dependency environment on the server, which is set up virtual env. That basically does the same virtual env setup steps that you guys did on your machine, but remotely on the server, more or less, right? So that's kind of everything that Fabric is helping us do. Now I'm just going to talk really quick about the real deployment environment. So basically, the three tools that I put together, and actually I could show you this visually so we get a total completion. PDFs. So the three tools that are kind of remaining, let's see here. Oh, right, over here. Is the web server itself for running in production, a way to communicate between a real web server and our Flask server, and then actually the last thing, which is the thing that's actually going to run this, which isn't visualized here. But basically, why do you need all these steps to get something live on a remote server? Well, we could run our Flask server on the remote server, right? Like I could, in fact, I had the dev server command to run. But the truth is that Flask isn't really built to run on its own. They kind of bundle that web server just for convenience for local development. It's not really like a secure web server that you're meant to run in production. So it's not a good idea to run Flask that way. Instead, Flask actually implements this standard called WSGI, which is like widespread throughout the Python community. And so any WSGI compliant container can run Flask applications. And so the one I prefer is uWSGI. It's very scalable. It's really simple. It's just a tool you can install with like apt-get on your servers. And all uWSGI does is it's like a little C program that you pass it some plugins like HTTP and Python. You tell it to stick or to create a socket in a certain directory. And then you tell it where your application is, which is this line here, and what the name of the WSGI callable is inside your module, which in the case of Flask is always just the app basically it's the whatever you declare as the Flask object. So in my module, I said like app equals Flask. So as a result, the callable is app. And then the Python home directory, which you need to use if you're using virtual env. And basically when you run that, there's now a bridge between your web app and any UWSGI compliant server. And my favorite UWSGI compliant server is Nginx. So Nginx is basically really simple to configure web server that's also very scalable. And this is all the configuration you need to make Nginx work with UWSGI. So basically, it listens at a port, it takes a server name. This is like some boilerplate to make sure that it's listening at the root path and going over to your app. And then this little location block here basically says, when you get a visit at the root path, I want to pass along to the UWSGI application that's listening at this socket, right? So it's just a little bit of boilerplate, but you can put together those configuration files, and you can run Nginx plus UWSGI on basically any web server in the world, right? Like Rackspace, Amazon EC2, whatever you want. Yeah, exactly. Yep, and it's a very nice replacement for Apache too, because it's under the like kind of concurrency 10K model, so it like scales up to concurrent requests a lot better than Apache does. Yeah. But.
If you already have Apache running, can you run Flask under Apache?
Yeah, so for that you have to use the official mod WSGI Apache module, and then you just point it at the Flask app just the same way you could point UWSGI at the Flask app. Yeah, there's some config for it. Yeah, this is very easy to set up, I have to say. So like basically, this is the entire config file, right? So that's the whole config file for Nginx, and this over here is the whole config file for UWSGI. Oh well, that's the whole command that runs, right? And yeah, go ahead.
So what exactly does UWSGI do? Is it starting a process that
Yes.
listens at that socket?
Yeah, so it's starting a process that listens at the socket. It actually like runs a Python interpreter in a kind of, they call it like a kind of production resilient environment. So like it'll detect if the Python interpreter crashes, and if it does, it'll auto restart it and things like that. It runs the Python interpreter, it has that socket, and then it has like a very efficient communication protocol, which the Nginx UWSGI plugin uses to talk to it. And so as the requests come in, UWSGI spins up workers with Python interpreters, and then Nginx spins up workers, and the workers talk to each other. And that's basically it. Yep, exactly. And you can actually tweak like how many concurrent Python interpreters you want to run, the number of workers, that sort of thing. But this is like the default setup, right? That's correct. Can't use globals. Yeah, that's right. And actually, if you want to use globals or global-like things, you have to read about Flask's support for thread local globals, particularly to handle that issue, which is basically like, there might be some case where you're okay with sharing state, but it'll only get shared within a single Python process. Yeah. So, yeah, go ahead. So I don't reuse it. I recreate it in the Fabric file. So if you actually look at the Fabric file here, setup virtual env actually goes and runs virtual env on the remote server, and then inside the virtual env runs pip install to install the requirements. So that's why you only have to do that as like a kind of setup step. Yeah, so actually that's an interesting connection, which is that the Python home environmental variable is all you have to set in order to make an application think it's using a virtual env. That's basically all that activate script does, is like it changes your Python home environmental variable and does a couple of other things that help on the shell, but that's it. Adds the deactivate alias, I think. So when you're running it with UWSGI, passing $H, which sets Python home, is basically the equivalent of running activate before UWSGI runs.
I know some other servers that do that
Yeah, that's another trick you can use. That's the other way to do it. Yep. And then supervisor is the last tool, which is kind of just a useful sysadmin tool for this, also written in Python. And basically what supervisor does is it lets you take any process that you want and run it as like a service that you can like stop and restart without having to learn all of the intricacies of like upstart and sysv and all of that crap, which no one likes to learn about, right? So supervisor basically just has a little Python config file like this. I just copied my uWSGI command line entry into here as the command. And then you can set the directory that the command runs out of, some arguments about logging and whether to auto restart it. And when you do this, you actually get a nice command line tool, which I'll just show you here on the server. So there's a nice command line tool called supervisor control. And what this tool does is you can type in status. I have a lot of stuff here, but you can type in status and you can see services and what state they're in and whether they're running. And you can even do nice things like tail-f hacknode1, and then I'm like tailing the log file for supervisor for that process. And so this is just like a nice way for you to sysadmin your system without really worrying about it too much, more or less. And all I use supervisor for is to actually run uWSGI, because uWSGI needs to run in the background, and then Nginx needs to talk to it while it's running in the background. Nginx you usually don't have to use supervisor for because you'll have like a Debian package or something, or an RPM package that'll background it on its own, right? So you can kind of leave that be, more or less. Yeah, and so this is kind of like what it looks like. You know, you basically have the web request going to Nginx, then talking to uWSGI, which is running under supervisor, and then uWSGI is talking to Flask, and then Flask is talking to your app code. So it actually seems like a lot of layers, right? Kind of wire everything together. But the way I view it is that basically we're picking the right tool for the right job here, and there's just a few pieces that are working in a pipeline. And basically Nginx only knows about HTTP. Supervisor only knows about managing services. uWSGI is a service that we're installing in supervisor, and all it knows about is converting HTTP to WSGI requests. And then Flask, all it knows about is WSGI, so all it knows is how to like receive those HTTP requests and respond to them. And so we kind of like understand fully how every piece of our web stack is working, right, from front to back. It's no magic here, right? It's just things moving through a pipeline. So, okay, so actually I think that brings us pretty much to the end. So now I think you guys have basically the 3 steps kind of covered. You can build a fake with static clickables and kind of prototype with, you can build a fake with static clickables and prototype with your kind of bootstrap live reload workflow there. You can wire that into an actual template system and then have Flask set up your URL routes for building a little bit of response, web request response on top of that. And then you can use macros and filters for code deduplication in your front end. And then finally, to ship it, you can just set up a remote server with Fabric, deploy code with these 3 guys, Nginx, uWSGI, and supervisor, and with a couple lines of code, store your first real data with MongoDB, right? And so that kind of gives you everything you need to go front to back, really lightweight tools, nothing that you need to avoid pretty much. So, so yeah, that's basically it. I'll now take questions and then also point you guys toward the survey they want everyone to fill out. So hold on one sec with your questions. Let me get the survey on the screen for people, at least. There. Here it is. So it looks like they have kind of a Google short link. Get rid of this one, make this one really big. And also, if you're in the Google Doc, you can already open it, but otherwise, yeah, you see people moving on the thing. So that's their SurveyMonkey survey for the tutorial. While you guys are clicking on that and filling that out, I'll answer questions. So you, all the way on the right. Yeah.
So how do you use Bottle? How do they
That's a good question. So I actually haven't really used Bottle that much. I mean, my guess would be pretty similar, like concept-wise. Do you know, does Bottle bundle any database functionality in?
I haven't used Bob.
Oh.
I've used Flask before, so that's why I was curious.
Bottle's smaller than Flask these days, which is kind of a huge irony. That's kind of funny. Yeah, I mean, I consider them pretty similar. I mean, ultimately, you have to pick one. But yeah. Yeah, go ahead.
I love Flask, but as a consultant, I find it hard to recommend it to clients these days. I would like to comment on that because it looks like kind of bad. No work on new work on computer recycling tools for more than a year. You know, if you look at the issues about that, the last messages that have been answered by Jonathan are like 6 months old, and it's still more likely than what's done.
Yeah, so I mean, it's a good concern about Python 3 upgrade. I mean, I know that that's actually been on top of mind for people there. I know that there's like some sort of long blog post explaining why, and
Really doesn't make much sense that more people
I can actually follow up on that.
yeah.
Is I think it's not a open source project. They're only making 2 versions, in 2 and 3, and 3 just got released. I think December or something. So I think that is a draft for working on it. But you're right, the bot is only 3.2 now. So and 0.9 the current version that actually released last year. So and it's I think we have 3 is a concern people have, but I think from the author's perspective, they want to give their point that we are not making the open source in 2 different versions. That's the idea.
Yep.
So my experience with Flask thus far.
So that's a great point. I mean, I didn't. What's that? Sorry.
I'm sorry, what about Flask would you say is not good for any improvement?
I mean, so yeah, it's a tough sell, as you said, just by how little it's already used and how little, I guess, it's community driven, but not as like, Django, you can point to a lot of sites that are used and powered by Django, and it's an easy sell when you can point to, all of these different, even governments now using Django in various branches, and that's a really easy sell. I couldn't say the same about Flask, and I guess you're getting kind of more of a stable product when you have like a full-fledged framework. Granted, not every project needs it, but I feel like when you're consulting, definitely needs it well.
So it's more a perception issue than an actual technical deficiency.
Well, I think it's perception, but I think the technical aspect is there as well. When you have something as large as Django, you've got so many more people testing it and kind of working out all the kinks, so to speak. Especially when you're delivering something to a client, the whole aspect of security really comes into play. Where Django has gone ahead and handled a lot of that for you, whereas Flash gets to do a lot of that on your own.
No, I think Django will be a really kind of sort of relational modeling,
Yes.
ORM, all those stuff, and I think you should do some other tasks that it saves sometimes right on the sites.
Yes.
It's a monolithic piece, you buy the entire thing, there's no pieces there for like, here, all you can just use it for URL routing, and that's all you can do. So there are things you can do with class and model that which if you take Django, you're taking control module, admin module, you're taking everything.
Well, that's why you use Pyramid, because it's modular. It's not the whole package like Django is. You can do the single file application like Flask, but it has way more people using it, testing it, finding out all the bugs that could possibly go into something you deliver to the client.
That's what's great about so many frameworks is that you can use the one that syncs with you to say this makes sense to me